Hello, everyone. So this is my Stat 220 Group 9 project video. This is me, Ethan Ribling. My other group members are Andrew Catalpa, Ryan Zerwig, and Michael Rouse. They helped me all with the code and everything and with abstract and all that. I've been elected as the presenter, so I will be presenting the whole thing myself. So first off, I want to get into a few things here. So first off, just going through the data set. And like I said earlier, we are doing our project on Chicago energy usage. So we will just be, seeing and drawing connections with models, things like that on energy consumption of different types of buildings in different areas in Chicago throughout the year 2010. Our original data set had 73 variables with roughly 67,000 observations. Our clean data set had roughly it went down to 17 variables with roughly 60,000 observations. Project summary, it's very simple. Pretty much, we just wanted to see, how consumption of thermal energy in households, businesses, and industries in the city of Chicago in 2010, and just see how it changes based off, location, or how it changes based off the season or the month and all that. So that's kind of what we're doing. Our general consensus or our hypothesis is that obviously as you go into the winter months, usually you will consume more thermal energy compared to the summer months, just because during the summer months you'll be using AC instead of heating. So it according to our graphs and linear regressions, we were correct, which I will get into a little later. So for, like I said, our research abstract, we wanted to just determine how thermal energy in various districts of Chicago changed over time. Kind of like I was saying a little bit ago, um, how how does different locations affect it, et cetera, et cetera. So now I'll go into our data dictionary. So, like I said before, these are all the variables that we cleaned all of our data down to. So as you can see, we figured that area is very important, building, so type of building that energy is being used in, subtype, number of levels. And then when we were cleaning our data, there's two main ways to measure amount of thermal energy consumed, whether that be in kilowatts or therms. We decided just do therms. So when I go later and show you our clean data set and like how we got to our clean data set, you can see that we got rid of all of our kilowatts, our kilowatt columns from the Excel sheet. So as you can see here, like I said, just therms in all the months. And then obviously total therms, so we want to see the amount of total therms that were used throughout the year 2010, and then the number of gas counts as well. So now going on to our data review. As you can see here, we have our original data set and our clean data set. You can view both of these and then see how they changed and how it got nicer and more tidy. So first off, like I said, just very simple standard. We loaded in all the data sets to clean, or we loaded in the packages to clean the data sets. So obviously tidyverse, Dippler, readr, all the basic ones. Next up, we uploaded the data set of Chicago energy usage and just pretty much changed the name of it into ours. Obviously, we need to get an overview of the variables in the data set. So we use the summary command, and then we renamed the data set to simplify each segment of the cleaning process. So pretty much like I said up here, this for energy usage one, we took all the data that we didn't want to use and changed that to energy usage clean one. So as you can see here, there's a lot of just mainly the kilowatt data here. And then when we're omitting to, or when we were going to energy usage clean two, we omitted energy usage clean one. So all this data would not be included in energy usage clean two. Then we just changed it from energy usage clean two to energy usage clean three, where we just tidied up the names a little bit and made it a little bit nicer. And then obviously we use the write CRV command to copy the data into a clean data. So a clean data set so it can be viewed in the hyperlink above. So next up, we would go into our data exploration here. So the data analysis. So like I said, this is kind of just what I said earlier, pretty much just explaining what all the variables were and all the code was, explaining how we had a lot of variables and observations and how we cleaned the data set and variables and observations and all that. So now going to our visuals here. Sorry, I'll move myself to the side here. Um, I'll go into the graphs. So, like I said, here's our code that we used for the graphs and everything. So this is code for the box plot of total overall therms by the month. So as you can see here, this is just the code here. And here's the actual box plot that we use there was that our studio gave us. So as you can kind of see here, just kind of going, it's basically going along our hypothesis that in the months where it is colder, so January, February, December, as you can see, there's a lot more therm usage than in the months of, June and July in the summertime when you're using your energy or you're using AC more than you are thermal energy. Obviously, there's a few outliers here, which is strange. There isn't really anything we can come up with for why that is. I mean, it just kind of depends on what the need was at the time. I don't know. But other than that, though, our hypothesis stays corrected with the general box plot, which is what I said down here. So then for our bar graphs, we want to compare locations. So for our two locations, we picked Albany Park and Irving Park. They are roughly a mile apart. We want to do that just because we didn't want to pick two locations that were vastly far apart from each other, because that could make obviously the data that could explain some data or why there's more thermal energy consumed here and not here, etc. So we wanted to see how if location actually does have an impact, because if it does, then it would affect, the places that are a mile apart. So here's the code outline for a bar graph for Albany Park, as you can see here. And here's the code outline for Irving Park, as you can see here. And here is the monthly therm use in each. And as you can see here, they both roughly had the same general shape. The only difference is that if you actually look at the amount of therms that were consumed here, you can see here in Irving Park, there's a much significant larger use than there is in Albany Park. As you can see here, they use roughly 3.6 million therms in the month of February, whereas in Albany Park in February, they used roughly 2.75 million. So the kind of general consensus that we came to was that maybe Irving Park is more of an industrial area compared to Albany, where Albany could be more of a suburban or residential area. That would explain why they potentially use more therms in those months, because they're heating up those big buildings and stuff like that. So that's kind of just explaining that there as well. And so kind of moving on then to our models. So we did a linear model on Greater Chicago. So this is kind of where we brought in the seasonal comparison. So we took the months of March, April, May, and we're going to compare them to October, November, December. So we kind of want to show going from the cooler months going into summer, and then going from the summer fall months into the winter, to kind of explain our hypothesis that it gets, when it gets colder, obviously more therms will be used. So let's kind of go through here. As you can kind of see here, our hypothesis stays the same. As you can see, there more of the dots are lower than the month previous. As you can see here with the estimated standard deviation, that also, or with coefficients, that's also explained. As you can see here, going from March and then going down to April and then down to May, there's less thermal energy used in all the months, just because they're getting closer to the summer. So AC is being used compared to, thermal energy. And like I said, just kind of explain that through here. And like I said, the code will be pretty much exactly the same for October, November, December, just because, I mean, all we're really changing is just the actual data that we are selecting. So like I said, here's the code for that. And then, like I said, once again, our hypothesis stays true. As you can see here in October, November, and December, and even with coefficients, thermal energy stays significantly lower when you're closer to the summer months and fall months compared to when you get to December. As you can see, there's a large spike here when the winter gets here and more thermal energy is consumed. So then our last model that we used was a CART model. This was of total therms used in Portage Park. As you see, here's the code here. So for this code, we had to use two different chunks because we needed a training set and a test set. And we mainly needed that because if we didn't do the two chunks, we wouldn't have been able to get all of these toll therms down here. It would only give us these two up here. The main reason is if for the training set and the test set, that was able to give us a predictive set, and with that predictive set, it was able to give us these values down here because these values would not be available without the predictive set. So as you kind of see here, just very simple analysis here of of the analyzed observations of Portage Park. You know, so you kind of just look at the graph and see all of that. So conclusion. So with our post-research abstract, we decided to stick to our original topic and examine which months use the most thermal energy. Additionally, we decided to choose comparing neighboring areas of Chicago and see how total thermal energy usage relates to each other. So final comments, obviously, like I kind of said before, our hypothesis stays true where as we get closer into the winter months, we will obviously use more thermal energy just because we don't have our AC on anymore. It's cold outside, so you will use more thermal energy. The one unexpected variable that we didn't think of was the location. We thought that was kind of interesting with the Irving Park and Albany Park being only 1.2 miles away, but the thermal energy consumption being that vast and that broad, in comparison. So, like I said earlier, just kind of with the assumption of that and all of our data and conclusions in mind, we do believe, like I said, that Irving Park is probably more of an industrial area compared to Albany Park, which is probably more of a suburban area. So that's kind of what I'm thinking and going along with. So hopefully this was inspiration. You guys learned something a little bit. So that's our group project. Thank you and have a good one.